Okay, so we are on the top of page 259 in section 2.14, talking about proportions. So page 259, sections 2.14. And so if you look at this first one, again, a lot of this is a little bit of review. It says, what is the cost per sheet? So again, remember that is a rate, cost per sheet. So that tells you to divide, and it tells you to take the cost, which was what, $3? And divide by the sheets. And again, remember, this is not a percent. The units don't match, so you're just going to go ahead and divide, and you're going to get about, I don't know, 2.17, and that's pennies, isn't it? So that's cents per sheet is what we have there. So about 2 cents per sheet. You could maybe write it in dollar form, like about 2 cents per sheet if you write it with the dollar symbol. But again, it's a rate, so you don't multiply by 100, you're not converting to a percent, and notice your units don't cancel. You still have dollars, you still have sheets. All right, let's look at the next one. The next one says they want to charge $3 for a roll. How many sheets need to be to bring the price up to 3 cents per sheet? Now, some of you might just kind of, I don't know, the numbers are pretty friendly here, so you might just intuitively know. So some of you might be like, well, if I have 100 sheets times 3 cents, that's $3. So you might just get 100 that way. But the other thing is we could say, okay, well, if we know that we want it to be 3 cents for 1 sheet, then if we want to make it $3, then how many, how many sheets do I need? I'll use X. And actually, this one's not too bad to just scale up, because you could be like, oh, I just need to scale this by 100, and I need to scale that by 100. And so you could just do that mentally and get 100 sheets. Or you could cross multiply and divide, like we talked about earlier. So, and again, it's hard for me to write with my finger here. All right, and then let's look at the last question. Let me go up there. Okay, is this a significant difference in the number of sheets? Okay, so we want to know, again, percent increase or decrease. So we went from, there used to be 138, and now we're going to 100. And again, remember, percent increase or decrease is focusing on the increase or decrease. So the first thing you have to do is figure out the change, which it looks like there's 38 sheets. And then you always compare to where it started from, or where it began, so sheets. And again, to get a percent, you always divide and multiply by 100. And again, notice your units match, so they cancel. So when you divide and multiply by 100, it looks like it's about a 28% decrease, which is actually pretty significant. And a lot of companies do this because, like with peanut butter, they don't want you to realize that there's less peanut butter in the jar. So if you look at a peanut butter jar, historically they probably were more flat on the bottom, and now they kind of have that dome at the bottom to just kind of scoop out some of that place, so that plastic will go up, so it looks like the jar hasn't changed. But in reality, if you look at how many ounces were in the jar, same thing, that would have gone down. Same thing with like chocolate chips, like you see the bags and they really haven't changed, but several years ago they were 16 ounces. The bags look the same, but there's more air in them, and now they're 12 ounces. So there has been changes as far as what's in the package. Sometimes they just put less and keep the price the same so that people don't really realize what's going on. Or sometimes they just charge more money, or, they do different things. All right, I do want to look at why cross multiplication works, because I think it's important not just to memorize tricks in math, but to think about what's going on there. So if you have, say, 2/3, and I'll put 4/6, these are equivalent, right? I just scaled it up by 2. But notice what happens when you cross multiply, you get 12 and 12. And it's because, in a sense, you're clearing the fraction. So you have 2/3 and 4/6. Now, you're not using, like, 6 to clear the fraction. You're actually using 18. So you're not using the least common denominator. You're just taking the denominators and multiplying them to get what you're going to use to clear your fraction. So 6 times 3 is 18. So notice 3 goes into 18, 6, and you get a 12. 6 goes into 18, which is 3, and you get a 12. So it happens that when you cross multiply, you're kind of secretly clearing the fraction without even knowing it. And that's why it works. So in a sense, you're just clearing the fraction. Now, you're not using the least common denominator. You're just using a common denominator. So, for example, if I have 3/8 equal to x over, we'll do 4. Okay, the common denominator, if I was going to clear the fraction, I could just multiply both sides by 8 and do it that way. But when you cross multiply, what you're really doing is you're getting a bigger common denominator. 8 times 4 is 32, and you're multiplying both sides by 32. 8 goes into 32 how many times? 4, and 4 times 3 is 12. And 4 goes into 32, 8 and 8x. Now notice what happened is, if you look at the original, you can see that 3 times 4 does give you the 12, and 8 times x does give you 8x. Okay, so the reason cross multiplying works is, in a sense, you are just scaling them to get a common denominator, and then you're just canceling the common denominator because you're scaling them up. All right, let's go ahead and let's look at number 3. Why don't you try number 3 on your own? But again, when you cross multiply, be careful. You're going to have to use a distributive property there because you have a number times a binomial. So make sure you use a distributive property. Try it, see how it goes, and I'll come back and we'll do it together. Okay, so again, this would be impossible to scale up in your mind because it would be hard to know what it is. So what you can do is you can cross multiply, and what you're really doing there is you're just really clearing the fractions. So I have -3, but notice it's times all of that, x minus 1, and I have 5 times all of that. All right, and so I need the distributive property, so I can clear those parentheses out, and 5x plus 5. And be careful over here, a negative times that is fine. A negative times negative is a positive, so just watch that. Now, as far as undoing our equation, notice that I have 2 addings in here. And so if I'm doing order of op backwards or doing the process backwards to get rid of it, I know I'm going to have to subtract twice. So I am going to go ahead, or add, or negatives, whatever it is. I'm going to go ahead and bring my x's to this side over here, so they're all on the same side. I'm going to add 3x to both sides, so that's going to be one of my adding or subtractings I added because I had a negative over here. So I get 3 equals 8x plus 5. Let's see, let me scroll back. There we go. All right, and so then this is my new equation here. So then to get rid of my second one, notice this is a positive 5. I want my, if I have my variables on this side, I'm going to want my constants on this side. So to get rid of adding 5, again, I'm going to use subtracting 5 because that's the inverse of that. All right, and then I've done my, notice I had 2 at the beginning, 1 here and here. So I'm done adding and subtracting twice. So now it should be the division step. So look where your multiply is, which is over here by your x. When they touch, it means multiply. So to get rid of multiplying by 8, you do the inverse. And so x is a -1/4. You could, I just simplified my fraction. You could turn it into a decimal and say x is a -0.25. Have to be a little careful with that type of answer. If it's a repeating decimal where you need to round or something, then a fraction's probably best. All right, go ahead and try number 4. And again, on problem solving, do your best. I don't really care how you solve it, just figure it out, and then we'll talk about the different ways. So I'm going to pause it, go ahead and try number 4 on page 261. Okay, so let's look at this one. So they want to make sure that they're giving a proportional tip. And again, I probably on a test wouldn't have you write this 8 different ways, but you know, or 6 or whatever, but let's just solve it different ways and then we can set up different proportions. So one way to look at this is to set up a proportion. So some of you might have said, okay, well, let's look at what they did first. So they did a $5 tip for a $21 pizza. So then they must leave this kind of tip for a $34 takeout. So again, they're matching like the tip over the total bill, tip over the total bill. And that just kind of made that worse. So maybe I will erase that and start over. Let me get back there. All right, so let me rewrite that so it's more legible. Okay. All right, so we have $5 over 21, and we have T for a tip all over 34. And again, at this point, you could cross multiply, and then divide by the 21, and you should get of about an $8 tip. Now, some of you might like percents better, so you might be like, do I have to do a proportion? And of course the answer is no. And again, cross multiplying is nice on this because do you see how the scaling between these is not very pretty? So that's why cross multiplying is come in. Okay, so some of you might be like, well, I'm going to divide, my units match, and I'm going to multiply by 100 and just figure out what percent of a tip they left. So that looks like a, 23.8% tip. And you're like, okay, well then we should leave the same kind of tip. So to use a percent, you always multiply. So you're going to multiply that by the $34. And you're going to be like, okay, we need to leave about an $8 tip that way. Now, as far as this question goes, yeah, there's lots. If you want to do proportions, there are a lot of proportions you can set up. As long as your units are consistent, you're fine. So you could go a $21 meal compared to a $34 meal. And then you could say the tip for the $5 meal compared to the tip for the 34. And notice units match. We have the 21, the cheaper meal over the more expensive meal, the cheaper tip over the more expensive tip to match. You could flip those around. So you could go $34 over, so you could put this in the numerator, $34 over the $21 meal. But then notice the tip would be, the variable would be on top. You could do something like that. Let's see, what else could we do? There's lots of different ways. So which ones haven't we done yet? We could do the first one reverse. So like the $21, put the tip on bottom. And then we could do the $34 and the tip on bottom to be consistent. So we have the pizza over the pizza tip. We have the takeout over the takeout tip. And again, as long as you set them up so that the units match, you should be fine as far as getting the correct answer. And just make sure it's logical. I mean, if you have a $82 tip on a $34 meal, probably not correct. Okay, go ahead and see if you can figure out number 5, and then we'll look at that together as well. Okay, so again, a lot of things we want to be proportional. So one of this would be seats in the U.S. House. Some states have high population bases, so maybe they should have more representation. Others have less, but we still want them to have some representation, not none at all, because we don't want, say, large population states like California having every seat in the U.S. House and then other states not having a voice. And so we are set up so that there are, let's see here, this is how many seats there are. And so then they use census data here to figure out how many seats we should get. So let's, for example, look at Florida. Okay, here's the population total. So again, I can either do percents or I could do proportions. So I could take the population of Florida, and I think I just looked with all the virus stuff going on, and I think it's like 22 million now, but evidently in the 2010 census it was this. So there's my Florida, and over the population of the U.S., right? And so I could just divide those. I have population of the state divided by the population of the U.S., and what is that, 463? I could multiply by 100, okay, and I got about 6.1%. So if Florida has 6.1% of the population, they should get 6.1% of the seats so that they have that representation. So to use a percent, again, we always multiply. Sorry, my finger's not doing very well there. But I'm running out of time, so we're just going to leave it times, 435? So that's times 435. And I get that they should have about 27 seats. Now, we'd have to watch rounding here, too. Now, the other thing you could do is set up a proportion instead. And when I hit 15 minutes, this is going to cut off. So if it gets cut off, I apologize. So then I could do how many seats should they get, like how many total seats out of the 435. Again, we could cross multiply. So you would multiply these two numbers and divide by the number by the variable. You should still get that 27, that's a 7, 27 seats for Florida House. And you could do the same for Ohio and Texas